Hey guys, Joe back at it once again with some A-level further maths topics, and today we are talking about tangents to a parabola. In the last lesson we introduced yourselves to parabolas, and if you've missed that, then obviously go check that out now because you'll be very confused as we get into this video. The learning objective for today is to know how to work out tangents and normals to parabolas. So here we go. Last lesson we talked about the parabola. We now know we can work out the equation of a parabola when given the focus and directrix and vice versa. Just like any curve, we can work out the equations of both the tangents and the normals to a parabola. Just like any curve, we can do this through differentiation. So there you go, that's what we talked about last lesson. We said the definition of a parabola is that if a certain point is equidistant from the focus, which is A0, and the line, which is called the directrix, x equals minus a, then it is a parabola, and this works for any generic point along the curve. And we call this generic point xy, but you know, xy in terms of a and t, we go parametric, which you'll come across in core 4. I might be doing some videos on them, but for now just think of it as a's and t's, and we're going to call it at squared and 2at. So yet again, the focus and the directrix, whatever that a is will determine the general point, the equation of the actual parabola, as well as the focus and directrix themselves. So here we go. So you start with y squared equals 4ax. If we want to get the tangent, we need a point and a gradient. We've got a point, so we just need to get the gradient. So first of all, we need to get y on its own, so we have to square root. So y equals the root of 4ax. Split that up into 2 root a root x, because you can just split a third into root 4, root a, root x, and root 4 is obviously 2, so it's 2 root a, root x. Now we want to write that in power form, which is that y equals 2 root a x to the half, because we're going to differentiate it, because to work out the gradient finder, we do dy by dx, power to the front, not 1 off the power. So there you go, dy by dx, the half comes to the front, cancels out the 2, and it becomes root a x to the minus a half, because we're not 1 off the power. That is better known as root a over root x, because that would be it would be root x to the minus 1, and to the minus 1 means go underneath, so it ends up being that. It's all dictated by that minus sign there. And to find the gradient at a specific point, we shove our x coordinate through, which is this fella up here. So by the way, you can just rewrite that as that, put the root all over and call it a over x. So when x equals at squared, dy by dx equals the root of a over at squared, and here we've got an a on the top and an a on the bottom, so we can cancel that out. So it's going to be the root of 1 over t squared, square root and everything, you end up getting 1 over t. So that is our generic gradient of a generic parabola to a generic point. The gradient to a generic tangent at a general point on a parabola. So we'll then turn to the line equation. Y minus b equals mx minus a, or you might know it as y minus y1 equals mx minus x1. And multiplying through by t, because I'm not a particularly big fan of fractions, and you end up with that. Be very careful, you have to power your t's. So it's ty minus 2at squared equals x minus at squared, and just taking the 2at over the other side, and you end up with ty equals x plus at squared, and that is the generic tangent to any parabola. So if you have any numbers, you know, you can work through that. So you will usually be just asked to do it generically, but if there's any numbers, remember it's all determined by the a anyway. The t's will stay the same generally. No, I was going to say they might change the letter, but it is 9 times out of 10 t, I would say. So that's the generic equation of the tangent. And working out the normal, as you might imagine, is almost identical, except it has the negative reciprocal gradient, just like normals to any curve. So when x equals at squared to y by dx equals 1 over t, so that is from here, if we look here, because it's going to be exactly the same, because we do it exactly the same. But remember, we do the negative reciprocal if it's the normal, because normals meet tangents at 90 degrees and perpendicular gradients are negative reciprocals of each other. So there we go. The normal gradient will be minus t. So y minus 2at equals minus t brackets x minus at squared. So there you go, and then just expand and tidy up. And I like to keep everything positive, it doesn't really matter, but y plus tx equals at cubed plus 2at, and that is the generic equation of the normal. So here's an example then. A parabola C has the, well, see, I was already proved wrong by saying that it might change the letter, and we've got a P here instead of a T, so there you go. And I got this straight off an FP1 paper, so that just shows how much I know. A parabola C has the equation y squared equals 4ax, generic parabola. The points P, AP squared, comma 2AP, and Q, AQ squared, comma 2AQ, lie on the curve C. Show that the equation of the tangent at P is given by Py minus x equals AP squared, and write down the tangent at Q. So, first of all, like everyone, we want the y on its own, so we root everything, then we split it up, write it in power form, dy by dx, simplify, put it all under one root, put in what x coordinate, the a's will cancel, square root everybody, and you end up with 1 over p. So that should just fall into your lap every single time you do one of these. It should work out exactly the same. Y minus b equals mx minus a, put in the numbers, times throughout by p, you end up with that. Have one eye on what the examiner wants to see, and he wants to see a negative x, so you just take him over the other side and you take the AP squared over, and you end up with what the examiner wanted, Py minus x equals AP squared. And you'll notice for 1 mark, the next question would be write down the tangent at Q. Very, very similar points here, AP squared and 2AP, AQ squared and 2AQ, so you might just be able to guess that wherever we see a P, we'll just replace it with a Q. So the tangent at Q is Qy minus x equals AQ squared. And that is that. Everything to do with tangents to a parabola in, what, about 8 minutes? Not too bad at all. So hopefully you guys have found it helpful. Make sure you leave a like down below if you do, or did find it helpful, because it helps me know that the lessons are of a good quality and that they're helping you guys out. Any questions you've got, leave them down below in the comments, and next lesson we'll be talking about the hyperbola, and that'll certainly be interesting. So I hope you really are having a wonderful day, and I hope that your I hope that your A-levels are going very, very well indeed. Just work hard and you'll be absolutely fine. So I'll see you guys in a couple of days for the hyperbola.